Hey guys, it's your teacher. Going to jump into the practice set here for lesson 83. So, if a spinner is spun twice, are the vents independent or dependent? Well, if you spin a spinner once, does that change anything? Not really. I mean, in real world, if you spin it real hard and the arrow pops off, maybe, but generally, no, it's completely independent. It doesn't matter how many times you spin it. It doesn't change the next spin, or it shouldn't, okay? Independent. And for the record, it would be 1/4 times 1/4 times 1/4 each time, if you're trying to get a specific goal. 4 different cards lettered A, B, C, and D are face down on the table with the order scrambled. As the card is turned over, it is left letter side up. So finding the A card first, your first option, you have 1 in 4 chance. Okay. Turning over A and then B. Okay, so your first chance is a 1 in 4. Your second chance is a 1 in 3. Technically, there's a slight change here in that if you're really getting into the very nitty of this, the fact if you turn over a B, you've gotten it wrong and it's failed, but whatever. This would be 1 times 1, which is 1, 4 times 3, which is 12. So 1 in 12 chance to first turn over the A and then turn over the B. Not impossible, reasonably likely. Turning over A, B, and then C. Well, 1 in 4 times 1 in 3 times now 1/2. 1/24 chance. Okay, much more unlikely. Finally, last one. You're suddenly if you've already gotten A, B, and C, there is no other outcome than D. So this and this are actually the exact same, right? So C, the 4-letter cards in B are face down on the table. Michelle turns over 1 and finds that the card is A. If she turns over the remaining cards one at a time, what is the probability that she turns them over in alphabetical order? Well, I think that's the same as this, right? Because A, B, C, and D. Oh, you know what? Sorry. It's slightly different because it's asking just 1 and 3, 1 and 2. That's it. Because she's already done this. She's already turned it. She wants to know the remaining cards. So she has a 1 in 6 chance of doing it. Sorry, I misunderstood the question for a second there. So this is C. That's B. D. Recall that the probabilities of an event and its complement total 1. In a bag are 6 marbles. 3 red, 2 white, and 1 blue. 3 marbles are drawn 1 at a time without replacement. What is the probability of red, then white, then blue? Okay, so first off, how many total marbles are there? We need that for our bottom number. 3 plus 2 plus 1, so 6. So what is the probability of drawing first a red? So that's 3 out of 6, or 1/2. Okay, so 1/2. 2 out of 6, which is 1/3. And then 1 out of 6. 2 times 3 is 6. 6 times 6, so that's 1 in 36 chance of getting a red and then a blue, white and then a blue. Okay. Except I realize that's incorrect, isn't it? What did I do wrong here? This would be what it would be if it was independent, but it's not independent. It's dependent. What I mean by that is the first chance is 1.5. The second chance is not 1/3, actually, because now I've taken 1 out. Okay, so the second one, 2 white out of 5, so it should be 2 out of 5. And my final one isn't 1 out of 6, but it'd be 1 out of 4, because there's now only 4 marbles left. Okay, so 1 times 2 times 1 equals 2. 2 times 5 is 10. 10 times 4 is 40. 1 out of 20 chance. Okay? This is the dependent. This is the independent. Each thing you do changes the next action. Okay? So, much like this, the number should be going down. What is the probability of not drawing red? So just not drawing a red out of a single drawing? The question here is a little confusing. I think it's just a single not drawing red. Or not drawing red, then white, then blue. I'll do both ways. I don't know which way it's specifically asking for. If my goal was out of the first draw to not draw red, I have a 3 out of 6 chance. Okay. If my first draw is not drawing white, then my chance is 2 out of 6, which would be 1/3. So 2/3. This is all the other colors. Okay. And again, if this is my first thing, my chances are 5 out of 6. However, if what they're trying, I think they're trying to get you to do an independent, you draw 3 marbles. The first one, it's like, okay, did you draw red the first time? So that'd be 3 out of 6. That's unchanged. But now we're at 5 because 1 marble has been taken down. So what's my chance for now not drawing a white? Well, there's 2 whites. We don't. The problem is this doesn't work anymore, really. Yeah, this is impossible. And the reason why, so what's the probability of not drawing a white? I don't know what I drew my first time, okay? I don't know if there's 1 white or 2 whites left. So this first one I can do because I'm trying to figure out specifically grabbing this specific one. If I specifically grab a red, and then I know there's 1 less red, and now what happens if I try and grab a white, right? So I know which one's being grabbed. This, what is the probability of not drawing red, then white, then blue? If it's asking, you draw 3 in a row, there is no way to solve this because you don't know which one was grabbed, right? So the first thing I've grabbed, all I know is it's not red. But is it white or is it blue? I can't solve this. So I don't know if there's 1 white or 2 whites left in here. So I know there's 5 marbles in there because the one's been taken out, but I don't know if the one that was taken out was white or red. Or blue or whatever, right? So it must be asking for this, and if the textbook has a different answer, I guess I could go ahead and look at it. It's wrong. There's actually no way to find that out. Okay. Yeah. Let me actually just pause and see what the textbook says. Okay. I figured it out. The textbook is just very poorly worded here. They're not asking you to figure out what the chance of digging in there, not grabbing the one you want, then not grabbing. They're asking specifically, what they're trying to say is, what is the chance of failing to do this? Okay. What is the probability of drawing red, then white, then blue? Now, what is the probability of not doing that? Okay, that's what they're trying to ask you. They're just really bad at it because that is not, it looks like a separate question, not a interconnected. So essentially they're asking, okay, if you have a 1 in 20 chance of succeeding here, then you must have a 19 in 20 chance of failure. Okay, That's what they're trying to ask you. But what they actually ask you is not the actual thing, right? They're trying to say, what is the probability of drawing in and not getting a red, and then followed by not getting a white, and then followed by not getting a blue? That is different than this. This is just generic failure, okay? This is like, what this represents here is, what if I got a red and then a white and then a red again? Okay, that's a failure, but it is not the failure that they are asking for. That's what this is. So this answer, the one that's in the textbook, is not the answer to this question, though they say it is. What it really is just the answer to failure here. Okay, so sorry if that's confusing. That's poorly worded. We'll go ahead and we'll move on to the last one, E. Gary's drawer has 2 black socks and 4 blue socks. If he selects 2 socks without looking, what's the probability they are both black? Okay, so 2 black, 4 blue. So 2 out of 6, right, is his first option. If he succeeds out of that, his next option is 1 out of 5, right? So 2, 30, or 1 out of 15. Okay? Which means he has a 14 out of 15 chance of failure. Okay, that's your practice set. Remember, your written practice is 14 through 25 all. Let me know if you have any questions. Peace.